In this lesson, you will learn how to write numbers in scientific notation. Scientific notation is a shorthand way of writing numbers that are really big or really small. For example, here's a really big number. It's the distance in between Earth and Mars in miles. And you can see that this number has a ton of zeros at the end. And it could be a difficult number to work with. And the same thing goes for this number over here, which is the radius of a gold atom in meters. And this measurement is also incredibly small. There's a lot of zeros, and it could be equally as difficult to work with. So scientific notation helps to keep track of all those zeros in a nice and organized way. And let me show you the scientific notation form. Scientific notation has the form a times 10 to the n. And I'm going to break this down for you. A is a factor, and this is going to keep track of all the non-zero digits in the number that you're working with. So in this case, it's going to cover the 3, 4, and the 8 in this number. And then your power of 10 covers all those zeros. And as you can see, I've left an n in here for the exact exponent, and that's because it's going to depend on the number that you're working with, whether the number is really small or really large, and how many zeros are in that number. And we'll see how when we solve some specific problems. And there's one last thing to note, which is that the factor has some limitations. It has a range that it must fall in between. So the factor a must be greater than or equal to 1, but less than 10. And I'll show you how to find the factor in the first problem. So let's convert the distance in between Earth and Mars from standard notation, which is the way you see the number here, convert that from standard notation into scientific notation. And let me just erase some of this writing, and then we'll get started. Okay, so we want to convert the standard notation for the distance in between Earth and Mars. So here's our standard notation number. And we want to convert that into scientific notation, having the form a times 10 raised to the power of n. So to do that, we're going to have to really look at the number closely. So let me write the number really big for us to take a look at. Okay, here's our number in standard notation, written really large, and let's find the factor first. So remember, the factor has to be greater than or equal to 1 and less than 10. And to ensure that you always pick the correct factor, the way you do that is you start from left to right, and you find the first non-zero digit in the number. So for a really large number, the first non-zero digit is going to be the first digit, and you put a decimal point right there after the 3. And the factor only covers the non-zero digits, so you only have to worry about this part of the number for the factor. And don't think about all these zeros for now. So this will be something later, and we're going to take care of that with the power of 10. This means that the factor is 3.48. So I'm going to write this right under where we have the factor written. And you can see that 3.48 is correct because it is greater than 1 but less than 10. So you're doing well so far. And now the next thing to do is see how many places you need the decimal point to move from the factor such that it ends up at the end of the number in standard notation. And what I mean by that is, see this decimal point here? The decimal point in standard notation is all the way down here after all those zeros. So you need to move that decimal point all the way to the right. And to do that, you're going to multiply by a power of 10. Remember that when you multiply by positive powers of 10, the numbers get bigger and the decimal point will move to the right. So to make sure you pick the correct exponent, you need to count every place value that the decimal needs to move. And I'm going to mark that with some hops underneath each place, and then we're going to count them. Let me do that for you. Now each place value that the decimal needs to move has been marked, and you need to go in there now and just count, and that's going to determine the exponent. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the decimal point needs to move 13 places to the right, which means that our exponent for the number in scientific notation is positive 13. Positive exponents makes the number bigger, and it moves the decimal point to the right. Okay, so that's how you write the distance in between Earth and Mars in scientific notation. And I'm just going to add miles here because if you are concerned with the measurement, you need to know the units, so include that in your problems when you're solving them at home. Now let's write a really small number in scientific notation. Let's go back to the radius of a gold atom. The gold atom is back now, and I've already gone ahead and written the number really large underneath so that we can work with it. And so we're going to take the number in standard notation, this number right here, and convert it into scientific notation with the form a times 10 to the n. So here it's a little bit different because this number is very small. So when we go to find the factor, we do the same steps that we did in the first problem. You start from left to right and find the first non-zero digit. So if you start from the left of the number and you go right, you're going to cruise all the way through here until you get to the first non-zero digit, which is a 1. So here is your factor. So in a really small number, the first non-zero digit happens after all of the zeros. So the factor is 1.35, and as you can see that it does fall within the appropriate range. So I'm going to write our factor right here. Now the next thing to do is count and see how many places this decimal point in the factor needs to move to get back to its original location in the number in standard notation. So let me go in and count each of those places for you. Okay, now I've marked each place that the decimal point would have to move to the left. And I've counted them for you too. So there are 10 total places that the decimal point needs to move to the left, which means the value of the exponent is going to be 10. However, here the exponent is going to be negative. And the reason is that exponents that are negative are like dividing by a power of 10. So remember that 10 to the negative 1 is the same thing as 1 over 10. So when you multiply by 1 over 10, and you continue to do that, if you multiplied by 10 to the negative 2, it would be multiplying by 1 over 10 2 times, the number is going to get smaller and smaller and smaller. So negative exponents move the decimal place to the left, so we're going to use the exponent of negative 10 to write this number. Okay, so now you have the number from standard notation written in scientific notation, and the measurement was taken in meters, so I'm going to include my units there. Now to check if you've done the scientific notation correctly, what I've done is brought back the original example we started with from the distance in between Earth and Mars, and I've kept the radius of the gold atom still here. Now I've shown you the number that you wrote in scientific notation. Here it is, 3.48 times 10 to the 13. And if I want to make sure that this is correctly done, what I'm going to do is expand the scientific notation back to standard notation. So to do this, look at the exponent. So here you have a positive power, and the power is to the 13, which means that the decimal point is going to move to the right. The number is going to get larger, right, because you have this positive power here. And it's going to move to the right 13 places. So if you're going to move the decimal point 13 places, and here's the decimal point, right? The first 2 places you move it, there's the first 2 places. So the first 2 places covers the non-zero digits. And then you have 11 more places to move, which means you're going to add 11 zeros. And let's write that out. So 3, 4, 8, right? We move the decimal place 1, 2 places. Now 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. And you can separate these in groups of 3 with your commas. And here you go, the number in standard notation. Now see if it matches the number that the problem said, which is up here. And if you look at these two numbers, they are the same. So 3.48 times 10 to the 13 is the correct way of writing the distance in between Earth and Mars in scientific notation. Now I'm going to work with the radius of the gold atom. Again, you're going to look at the exponent here, which is negative 10, which means the decimal point in the factor will move to the left and the number will get smaller. The first place, you move it 1 place, you cover the non-zero digit here, the 1. And then you have to add 9 zeros in front of that 1, and you'll have the correct number in standard notation. Let's do that. So 0 point, and now 9 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the factor, right? And I added 9 zeros, remember, because I already moved the decimal point 1 place to cover the non-zero digit, and I had 9 places to move, so I filled it in with zeros. And see if this number matches the problem. The problem right here is shown, and then these two numbers do match up, so you wrote the number correctly in scientific notation. So just remember a few things when you're going to write numbers in scientific notation. And that is that negative exponents move the decimal point to the left, and they're used to represent small numbers or to write small numbers. And positive powers of 10 move the decimal point to the right, and these positive powers are used to express numbers that are really large. Okay, so you've learned a lot about scientific notation, and I hope that this makes solving certain problems a little bit easier for you.